Hello students, this is Dr. Rush here. This is my first attempt at making a video, so bear with me. It'll get better, I hope. So I promised you something on solubility. Oopsie do. Okay, let's try to get a pen here. Solubility. So you should all have a handout on this. Solubility rules, okay? So I give you a little piece of paper with 6 rules. Okay, so solubility refers to compounds. It's what we are caring about here. Compounds and they're ionic compounds. So they're compounds of a metal and a non-metal. And the non-metal can either be a monatomic anion or a polyatomic anion. Okay, and the metal is always a monatomic cation unless it is the polyatomic ion ammonia. Okay, so solubility rules tell you 2 things. It will tell you if something will dissolve, and dissociate if it's an ionic compound, or it tells you if you have a reaction whether or not it will precipitate. And precipitate, my handwriting will get better as I go along, means form a solid. Dissolve, dissociate, of course, means you need to put an aqueous state symbol by it. Okay, so let's go over the first rules. And the first rule on there I call trump cards, because if these are present, these well, they're cations and anions, then it doesn't make any difference what else they're paired with. They determine the solubility. So the trumps are number 1, and they determine solubility. So you don't even have to worry about the rest of the stuff. Okay, so the trumps, there are 3 cations that are trumps, 3 types of cations, and they're always soluble. Okay, so we're going to worry about the ones that are always soluble. And those are group 1 cations, and you know what those are. Those are the alkali metals. And the group 2, oops, not true, just the group 1. What did I say, 3? So I've made a mistake. So it's just the group 1 cations are guaranteed to make compound soluble, and the other thing is the polyatomic cation ammonium. Okay, so if a group 1 element or a group 1 ion is the cation, it's soluble. And if ammonium is the cation, and that's not ammonia, it's ammonium. Woo! What does that say? That's a U, and that's an M. Then the thing's gonna dissolve. So what does that mean? Let's just take an example. So if I put, let's try, hello, sodium, anything. So let's put sodium carbonate. And you can see from your list the carbonates usually aren't soluble. Sodium carbonate solid. If I add it to water, since it's soluble, I'm going to get complete dissociation into ammonium. And carbonate. Okay. So if you were asked about what is sodium carbonate, you'd say soluble. And why? Well, it's the cation that determines it. Trump card, group 1. Oh, my God. Another mistake. This is insane. That's sodium. Boy, I'm going to need a little editing here. I got to learn how to do that. Nutty. Okay, it's very late. Wouldn't matter though, frankly. Okay, so sodium carbonate will dissolve into sodium cations, carbonate anions. Forget about the ammonium. I don't know why that's stuck in my mind. And the sodium is the determining factor. All right, so I'm going to get a new page if I can figure out how to do that. I think that's this. Oh. Okay, so there's some other trump cards. And those are the trump anions. And there's more of them. Okay, they are all polyatomic. Okay, and so if they're in their compound, it's going to dissociate into ions. You're never going to be able to make precipitate out of one of these ions and anything. Okay, and those ions are nitrate, which is NO3 minus 1. See if I can get these right. Perchlorate. Ooh, perchlorate. Not quite as professional as Con here. Chlorate, ClO3 minus 1. Okay, and the other one is acetate. I'll give you a little I'll give you a little hint. I'm not going to write this down, but I think silver acetate is right on the cusp of being insoluble. But these are trumps. So if I take anything, okay, a lot of lead compounds are not soluble, but if it happens to be a nitrate, ooh, lead, nitrate. So if I want to just get some lead in solution for you guys, I go into the lab and I'll pick a nitrate because I know when I put it in water, I'll get lead plus 2. And I'll get nitrate, oops, AQ. I got to be careful with these state symbols. I hate to write them. That is an AQ, and I'll get nitrate. Okay, 2 of them, right? So it'll give me a source of lead plus 2. So nitrate is a real popular anion because, you know, I got to go on this. If these things are solids, most of the things I go in the storm and get are solids. We don't store a lot of water in there. And if I want a solution, I take the solid thing, I put it in water, and I get ions. And this is going to be what? Always in solution. Remember the name? A spectator. Never gets involved. Well, actually can get involved in redox. It's never going to get involved in precipitate. So same thing for perchlorate, chlorate, acetate. I'm going to assume you know how to memorize those. Okay, hopefully I can go a little faster now. This is going to take a long time to say nothing. But I guess that's, I'm going to try to get a new page here. Okay, I hope I am recording this. That would be unfortunate. Okay, now, after those things, those trumps, so they're easy. Nitrate, ammonium, those are your main things. Group 1, cations, perchlorate, chlorate, acetate. They're always soluble. Cannot make a precipitate. Always make ions. Then we get things that are a little more complicated. And I'm going to give you some handouts. Also put on the wiki, but I don't think it's going to go on the wiki tonight. I think Dr. Rush is going to get in the bed after this. Okay, so 3. Now we get to things that are usually something. Not always, but usually. So they're not trumps. Okay? So let's start out with the usually soluble. that are common. Now, obviously, there's a lot of things in this world, but you don't have to worry about every cation and anion. Just worry about what's on this list. That's good. And don't worry about fluoride for right now. Let's just worry about chloride. Underneath that, as you well know, is bromide and what else? Iodide. Okay? So those halogens that don't include fluoride are usually soluble. Okay, what makes them insoluble? Well, we see these usual suspects. Insoluble with silver. Silver compounds are notoriously insoluble, unless, of course, they're with a nitrate. Lead plus 2 is notoriously insoluble when paired with anything. Oh my gosh, get out of there. Running my perfect thing here. And also this. Now, what the heck is this? Well, it's mercury. And I'm going to put mercury, and it's a plus 2 charge. But I'm going to put a subscript 2. So what is that? Is that mercury plus 2 or mercury plus 1? Well, this is actually mercury. Have you guessed it? 1. So that's how we write the mercury with a 1 charge. Mercury's funny. It always comes around in a pair. It's a dimer. That's what we call a dimer. Di. Two mers. A mer is just a group. Okay, so that's actually 2 little mercury ones hooked together. I don't know why. It's some quantum effect, some relativistic effect. You're going to ask Stover about that. So each of these are plus 1. So this thing is, hello, plus 2. So these are really 2 mercury ones stuck together. That's important to remember. Okay, usually soluble. Next page, please. Now, by the way, one nice thing here is you don't have to listen to this whole thing at once. I don't even know how long I've been going on, but I bet I'm bored. So you probably are too. So you can save this for later. You can watch it tomorrow on your smartphone, etc. Okay, 4, another usually soluble group. Okay, so now we got some polyatomics here. Okay, and those are, well, one of them, actually there's one of them, sulfate, SO4 minus 2. That's sulfate. It's usually soluble, but I don't go to the store and pick up a sulfate compound. I usually go get a nitrate because it's always soluble. But this is usually soluble, so I put it in water. Anything that has a sulfate as an anion will probably dissolve. Except, okay, some of our friends that we've seen before. Mercury, except if the cation is mercury 1, right? Hg2, 2 plus. Okay, if it is lead 2, seen that before, that little booger. Okay, or what we call heavy group 2, the heavy alkali metals. Okay, we're not going to worry about the radioactive one, but that would be barium, right? And what's below barium? Look at your periodic table. You should always have one handy when you're doing chemistry. And maybe not. You memorized it, right? Calcium plus 2, and below calcium is strontium plus 2. So, what does that mean? Well, let me do the insoluble one. So, if I take barium, and I add it to, we're going to forget where this came from. There had to be some sort of spectator cation with it. It would make BaSO4